Hello and welcome you all to AN Automation. Today we'll discuss about the topic of Profibus network, how Profibus networks are used to implement in industrial automation, and how Profibus is used to communicate various master slaves and various devices, slave to slave, master slave devices accordingly. So let's go to the topic. So what is the Profibus? Profibus is fully named as Process Field Bus. It is a standard for field bus communications in automation technology and was first promoted in 1989 by BMBF. It's a German Department of Education and Research Center, and then used by Siemens. And field bus refers to the network protocols used for real-time distribution of control. So Profibus are basically two types. One is Profibus DP and another is Profibus PA. What is Profibus DP? DP full form is decentralized peripheries. It is used to operate sensors and actuators via a centralized controller in production's automation application. It is a high-speed bus interface for connecting remote I/O, actuator, and other intelligence unit. And what is Profibus PA? PA is full form is process automation. It is used to monitor measuring equipment via process control system in process automation applications. This variant is designed for use in explosions or hazardous area. This is a low-speed bus designed for direct connection of transmitter which can be powered over the bus cable. Due to this feature, this bus is especially suitable for use in hazardous areas. So what is Profibus DP and its functions? Profibus DP is used to two-core screen cable with a violet sheath and runs at a speed between 9.6 kbps to 12 mbps. It only allows 31 devices to be connected at once. More than 31 devices are to be connected via repeaters. More devices up to 126 can be connected or network expanded with the use of hubs or repeaters. 4 hubs or repeaters to each 126 nodes. And what is Profibus PA? Profibus PA process automation's functions are: it runs at a fixed speed of 31.25 kbps via blue sheath 2-core screen cable. The communication may be initiated to minimize the risk of explosion or for the system that instinctively needs safe equipment. The message format in Profibus PA are identical to Profibus DP. Profibus Fact: 128 addressable nodes on a network is available in Profibus. The Profibus protocol supports address from 0 to 127. However, address 126 and 127 have special use and may not be assigned to operational devices. Thus, the address you can use for operation is devices are 1 to 125. The address 0 is typically set for the programming devices, and address 126 is default address for a slave with the software control setting. Address 127 is a broadcasting address, and address 3 is a factory default for many devices with physical address settings. So to get a detailed view on the how topologically we arrange the Profibus modules or Profibus devices in a same topology from the network ID 1 to network ID 126, we can demonstrate the actual scenario to connect the devices from node address 1 to node address 126 in the topology will be here. So first we take an PLC as a controller, which address is select as a 1. Node ID is Profibus node ID, which will be 1 for the PLC or controller. Then we will have to access the address number 2 to 31 for its IO module or any other drives or any other etc. Some modules rather than Siemens is ABB drives or Schneider drives etc. We need to access it from in the network ID 2 to network ID 31. Then we'll have to you can directly connect the Profibus cable up to 31 addresses to access the node address 2 to node address 31. After this address 31, we need a repeater. We need a repeater to access the more 31 node IDs to access it. So when we need when we connect a repeater, we can access the node address of that 61 up to 61. From the node address 32 to 61 can be accessed by using the one repeater in between the system. So we need to access more addresses, so we need another one repeater here to access more addresses from address 62 to 91. And then we need another repeater to connect with the address 91 to 121, 92 to 121. There may be some ABB drives and Snyder drives, etc., HMI. We need another repeater to access the more addresses like 123, 126, 125, 126, etc. So if the IO modules or the drives are in Siemens, belonging to Siemens platform, then we no require to install the GSD file in the Semantic Manager or TI portal, or any other platform portal, to access the another system house product like ABB, Siemens, Schneider, etc. But when we use the ABB or another system house product like ABB, Schneider, then we need to specify the GSD file to install to access or communicate with that module for our system. Sometimes some GSD file will be required for Siemens systems also. There are some specific devices or specific model name, model IDs, manufacturing units, they need required to GSD file, otherwise they are not communicate. So you can see the addresses of the IO modules, controller and drives, HMIs are defined in the series. But here you can see the repeater, we don't need to put a address. We don't need to address a repeater for its workability. So we don't need to address a repeater. Okay, without addressing we can access from address 1 to 126 via controller, via using this 4 repeater. In a node or in a typical node, we can use only 4 repeater, which we have earlier mentioned in our presentation, that we can use only 4 repeaters in a topological network. And we by this 4 repeater we can access up to address 126. 126 is basically broadcast address. We can't use it, basically defaultly is not present in the system or topology. And address 0 is also cannot be possible to access because it's primarily blocked. Okay, so in this topological view, you can easily see how a Profibus topology will work or is working. So what is the applications layer, or what is the OSI layer 7? OSI layer, to use this function, various service levels of DP protocols were defined. There are 3 defined protocols are there: DPP0, DPP1, DPP2. DPP0 and DPP1 is we can see in the Semantic Manager we can use, but DPP2 is not available right now for the Semantic Manager any other platform. It's just a practical theoretical level example that there are 3 protocols: DPP0, DPP1, DPP2. So what is DPP0? For cyclic data exchange, the data and diagnosis. It is a foundation for the Profibus and was the first version of the FMS. What is field message specifications? DPP0 came from the optimization to the FMS, the original Profibus protocol, to support the fast IO data exchange. Basically every module we have connect in the topology, there initially DPP0 is default setting have been there. So what is DPP1? DPP1 is a cyclic data exchange method and allow handling process. It comes with the address added extension that allow runtime reading, writing of parameters for more sophisticated devices such as intelligent drives. For example, the Profibus PA field instruments such as valve positioners, pressure transmitter, and so on. DPP2 for asynchronous modules and data exchange broadcast, slave to slave communication. It is primarily added to extension so that you can perform motion control applications directly across the Profibus rather than the required a secondary motion control bus. So by this description you already understand. So by this pictorial view or graphical view, it's represent the functional levels of the various functional levels and device features with respect to time. Profibus DPP0, DPP1 and DPP2. The functional level and device features is increasing with the DP versions. So DPP0 we use is cycle for cyclic data exchange. DPV1 is acyclic data exchange, and DPV2 data exchange between broadcast publishers or subscribers. So on another view, we can see that the device functionality is depending upon the this chart. DPV0 is cyclic data exchange, which I earlier mentioned. DPV1 is a cyclic data exchange between master and slave devices and alarm handling. But DPV0 is have separated diagnostic reporting features which we have, and DPV2 is for deterministic cycle time mode. That means we can communicate or synchronize our master and slave in proper RTC, with real time clock, and slave to slave communication, data communication can be done in DPV2, and uploading and downloading through the PC or PG can be done with DPV2. So we can see the standard cable length of the Profibus network. Here we can see baud rate increase. When baud rate is increasing, the segment length of the Profibus network is decreasing. You can see 9.6 kbps. For 9.6 kbps we can use 1200 meters, 1200 meters of 1200 meters of Profibus cable. For 19.2 kbps we can use 1200 meter of Profibus cable, and 40 up to 93.75 kbps we can use 1200 meter Profibus cable. But here have a in here have a catch. After the 93.75 we can see up to from 187.5 kbps we can see the cable length is reduced. 187.5 is a default baud rate for MPI adapters. Up for 500 kbps we can see that is 400 meter, 1500 kbps for 200 meter, 3 mbps 100 meter, 6 mbps 100 meter, and 12 mbps is also 100 meters. So here we can understand that the baud rate is inversely proportional to segmental length. Not mathematically, just to understand, you can elaborate this like that, but mathematically it's not quite relatable that baud rate is inversely proportional to the segmental length, but just is for understanding the view of the baud rate and segment length of the Profibus network. There are one more consequences. The fastest baud rates that can be set for a network is limited by the slowest device on the network. That means in 100 meter segment, 10 device at 1200 kbps or 12 mbps, one device is 1500 kbps, then the network maximum speed will be 1500 kbps. That means the minimum baud rate module have the which module have the minimum baud rate, it will be the network baud rate for your whole network. So but here is the situation. Your two devices are situated in 500 meter and 1000 meter distance, but you need to faster your band baud rate. Then what is the solution? Answer is the solution is optical link module. Optical link module is the platform where RS485 you use a Profibus cable in one side, and in another side the Profibus the optical link cables will be connected. By this the wired connection is wired communication is converted into optical communication. In this way the baud rate is quite we can get the baud rate quite higher than the conventional RS485 or Profibus communication cable. So this is the OLM module. This is the front view of the OLM module. Here you can see the systems and the some LEDs here, and here is channel 1 and channel 2 to both optical both Profibus cable are will be connected here, and in the topmost area you can connect, you will have to connect the 24-volt supply for operating to operate this optical link module. You can see there is a channel IO 1 by 9 pin D connector is RS485, and in the down in the other side you can see the DIL switch of the module have been here. Operating voltage is connect will be connected from here. Sockets for the measuring level of the optical interface will be here, and you can see channel 2 or channel 3 are optical channels will be connected from the below portion, bottom portion. So let's come to the 1 meter rule. Profibus cable should never be shorter than 1 meter between two nodes. If you have troubles at 1.5 Mbps speed, lower it to 500 kbps and test if it helps. You can see reflection if two nodes are connected between 1 meter, the reflection is quite higher, but okay with 1 meter. But if the communication cable is between two nodes is greater than 1 meter, the reflection rate is quite small. So it is better to communicate two Profibus node via cable which at least a length of 1 meter, which having a at least of length of 1 meter. So where the cable specifications? Cable specification, you can see the parameters and specific limits: impedance, operating capacity, loop resistance, wire diameter, wire CSA, LR proportional Profibus, DPIS will be mentioned here. So Profibus string and shielding. So you can see here the Profibus. This is a basic Profibus connector. You can see the in the black and white picture is a basic, and it has a PG, and the left the color one have a PGPC port. You can connect the PGPC interface direct to via MPI cable from here. Okay, now you can see that the Profibus cable is coming here, and the shield is connecting. This is a shield is connecting through this, and the Profibus 2 cable red A and B are connected to the Profibus link area. Okay, so you can see the number one. What is number one? Number is a 9-pin D connector for connection at the station, pin 3 and pin 8. 2 is housing screw. You can see the housing screw is here. 3 is screw for fastening to the station. You can see these two screw are directly connected with the module. Okay, you can see in your PC when you there have a dedicated 9 pin on 13 or 19 pin jack, but there have a two screw connection there to attach it properly. So these screws are for that, to attach the Profibus connector with the 9 pin D socket properly. 4 is insulation. What is a 4? 4 is insulation. These two are used for insulation between AB1 and AB2, line incoming and line outgoing. Strain relief, 5 is strain relief. Here you can see there are one screw. Okay, this screw is used to hold this Profibus cable. Thus these two small cable cannot be fall out or break out. 6 is the guide. Where is the 6? 6 is the guide. This is the guide where we'll have to strap our Profibus cable. You can see definitely this type of Profibus cable. There you can see the ash color thing is the shield. The shield is properly grounded. Okay, the shield is properly grounded and connected to the shield area, and the two Profibus cable red and green are going through A1 and B1, and outgoing is A2 and B2. Here you can see the on off connector. If it is the last node, basically they had two Profibus cable is coming, so particularly this switch is remain in off position. Okay, so this is an ABB 582 and PM592 Profibus communication module used for communication purpose of ABB 500 series controllers. So there is a DPD 32.0 Profibus DP communication module, and an optional device for the ABB motor controllers UMC 100.3, which enables the connection of the UMC 100.3 to a Profibus network. The UMC 100.3 with the PDP 32.0 is considered as a slave on the Profibus network. So there are various now we are discussing about the various kinds of Profibus CP cards or external module cards used in industrial automation. Okay, so this is an EBB 500 series PLC module which have a inbuilt Profibus communication port used for communication purpose. In this controller, no additional communication module will be required for Profibus communication. Okay. So along with the drives, this is an FPGA 01 card used for communication purpose of AC ACS 880, 580, 580, 850, 480, 380 and 355 series module, and ACS M1 and ACH 580, ACQ 580, etc. DCS 800 drives. They have also RPB 01 card available for communication purpose of the ACS 550 and 800 drives. Okay, so this FPGA card is dedicatedly designed for ABB drives to communicate with the Profibus network, but you need a proper GSD file to communicate this FPGA card. Okay, now in Siemens, this is a Symantec C plus 7 S7 400 CPU 416-3 PN-DP. You can see here in this CPU module inbuilt two numbers of DP ports are available there, and two numbers of Profinet ports also available in 400 CPUs. So this is a 300 controller which have an inbuilt MPI and DP port for the Profibus network communication. Okay, there have a dedicated Ethernet ports also, you can see. Okay, so this is a S7 1200 controller which don't have inbuilt Profibus connection slots. So via using CM modules we can communicate S7 1200 controller in Profibus. Communication module or communication processor, CM means the communication module, and CP means communication processor. The CPU range from this to this, we need properly CP card, and this from the digital SB and analog SB we can see the CPU. This to this we can use signal module or signal adapter. So S7 1500 controller will also don't have its Profibus connector port itself. We'll have to attach separate same module for communication in Profibus network. So 1500 is the updated version of all the PLCs used in Siemens. It's a latest PLC have developed by Siemens. Okay, the communication module CM1542-5 for Symantec S7 1500 on Profibus DP we are used for communicating with the Profibus node. The communication module CP1542-5 is intended for operation in an S7 1500 automation system. The CM1542-5 allows the connection of an S7 1500 station to a Profibus fieldbus system. The CM1542-5 operating as DP master supports the measurement of the Profibus topology in DP master system using a diagnostic repeater. So in G120 system, CU250S-2 has X127 slots for Profibus communication. You can see from this bottom position below the controller module, you can see the Profibus communication segment to use communicate in Profibus. In S120 drive, CU320-2 DP has dedicated X126 slots for Profibus communication. Here is the X127 slot. You can see the Profibus communication can be held through that, or other you need a dedicated separate this. If this port is damaged, you can order a dedicated external slot, Profibus slot, to communicate through this portion. For V20 drive, we need to do the following arrangement for the communication. You can see directly the V20 drive don't have any 9-pin D connector socket, so we need to connect the Profibus cable via like this. There you can see that red and green cable are go through there, and aim is properly grounded from the CPU, and the communication between the drives is the normally P and N are connected through this, and 0 volt is properly grounded with the TA. And you can see in the last node we will have to arrange like this. From 10 volt we used 1.5 kilo ohm resistors, and then paralleling through the 120 ohm and the 0 volt will be connected to the 470 ohm resistors, and the P will connect directly to the junction point of 120 ohm and 1.5 kilo ohm resistors, and the N is properly connected with the junction point of 470 ohm and 120 ohm resistors. In this way, V20 drive can be communicated in the via the Profibus. Okay, via the Profibus communication. So here you can see the Profibus or Ethernet protocol. How can we use from PGPC, and how the Profibus is directly linked with the this PGPC module, and then it's supports to the Profinet or other industrial Ethernet protocol easily. Here you can see the Profibus PA to Profibus DP converter we use for this type of sensors and transmitter devices. Then is connected to the Profibus converter. Then we can see the Profibus DP has been connected to the dry PLC, HMI, etc., and then it's communicate with the servers or the PG or the engineering system, and it's directly communicate with the mainframe network, that is industrial Ethernet or industrial Profinet system. There are mainly three types of connectors we are used in modern industries. There is one in 45-degree angle connector, one is 180-degree angle connectors, and the last is the 90-degree angle connector. This degree angle connector is totally depending upon the slotting of the Profibus cable through the connector. You can see the slotting will be here 45-degree angle, here is a 180-degree angle, this is out and this is in, and this is a 90-degree angle. You can see directly from vertically it will insert it and out, inserted and output will also in vertical connections. So this is the 45-degree connectors mainly used for communication, and it will have a dedicated PGPC port in its back. The following provides the product information of the Profibus bus connector with and without PG socket. This here you can see this connection. This type of connector can we get with or without PG socket. This is the PG socket up to 12 m baud rate, but 12 Mbps. You can use the Profibus bus connector to connect the station with an electrical line pin D interface according to the IEC 61158-2 directly to the symmetric net Profibus lines. Electrical segments or individual station can be connected to the optical link module. Stations programming devices connected to the repeater. So here is the internal view of this. You can directly see this is the Profibus cable which are connected to this, and after the connecting we have to these two types of screw there to properly hold it tight there. Okay, and after the connection of this, we'll have to close this flap and tight the screw at here and here to properly connect the system. Bus connection for the first and last station on the Profibus cable must always be connected on the left seam marking A1 B1. Bus connection. Here you can see the properly we have devised that what is the maximum electrical rating. MPI Umax is 28.8 volt, 150 milliampere. DP Umax is something like that, and here you can see the internal resistance formation of a normal connector. Here you can see the RS485 Profibus connector is there. Profibus is connected directly to another connector. Here you can see the in and out is there, and the electrical connection, electrical or circuit diagram is describing here. This is the on off switch, where if it is on and off, what will be happen, you can directly see from here. So this is the another kind of 90-degree. This is another kind of Profibus connector. This is a 90-degree connector basically used for this. Have a PG socket, and this connector we also have a without PG socket options there. This is the internal view of these types of socket. These types of socket don't have the screw. You just need to put your Profibus cable and press it down. It will automatically communicate with this arrangement. Here is the system setting of these types of module internal circuit diagram. if you want this PDF or this presentation, we can share with you by the YouTube link. Okay, YouTube description we will provide the link of the system. You can check it if you require the circuit diagram of this. Okay, so Profibus, what is the Profibus fast connector? With a fast connector, the mounting time is extremely short due to its connection and techniques integrating closing resistance simply assemble. So first step one, we'll have to cut the Profibus cable with the Profibus cutter. Okay, then we'll have to put it to the Profibus slots of the fast connectors. Then we will have to screw it down. Okay, then and the system is ready to communicate. This is the three types of fast connectors available in the industries. Here is also 45-degree, 90-degree and 180-degree slotting have been here. So what is the fast connector? You can see the video. You can see from the video. Okay, here is the fast connector, and these types of tools are required for connecting the Profibus cable to the fast connector. You will have to hold it and unscrew the connection area. You can see that there have two dedicated dedicated indication have been there for incoming and outgoing. After unscrew the area, you will have to just connect the Profibus cable through these two hole. Okay, you can see now by Profibus cutter we are cutting the Profibus cable with proper segmented area. Now the Profibus cables are ready, cutted in two portion. This red and green portion we will use in Profibus into the Profibus. Okay, now we'll have to cut the sheaths of the cable. This is a synthetic sheaths are having there in Profibus cable, which we'll have to cut it. You can see the diameter is 11 mm and 6 mm. Then we'll have to put it into the connecting slots. You can see it have been put in the connecting slot, and by pressing it will be connected. And for more precisely dedicatedly connection or for braking or safety, we'll have to screw it up. Now the screwing is done properly and the cable is connected. There have a on off switch also. You can see there have dedicated LEDs for power, TXD, termination and errors. You can dedicatedly get that there are power, TXD, termination with this video. So now we'll have to see that how it will work. You can see when we connect the Profibus cable, there are a power, TXD means transmission. Okay, transmission is blinking because it is directly transmitting the Profibus cables, and termination is okay. That's why the termination is turns to green, and no error is present in the line because the line is communicating. Okay, if we set this on off button to off, okay, now you can see the error will arrive and termination will be fall down. Here you can see we are put this to off, and you can see there have a error come and termination goes off. In this way you can monitor and observe via this fast connector. This is also helpful to monitor properly that which module is errorful or which module have compromises its errors. Okay, so
Phoenix Contact provides powerful Profibus ideas. The bus repeater increases the range of transmission and is used for potential segmentation. The bus connector is fast and easy to install. Strip the cable, insert the conductors, screw on the housing, and it's reversible for all cable directions. with optional programming unit connection, but always with fast connection to the modular inline I/O station. Absolutely fast and absolutely fail-safe, the Profibus optical fiber converter. Absolutely fast and absolutely easy, the fast connection plug for optical fibers without crimping, gluing or polishing. Safe and practical. Profibus device.
So in this video you can definitely see how a Profibus connector is work. So now we'll discuss about the troubleshooting methods of the Profibus network, how we can troubleshoot any problem like communication problem, communication breakdown with the Profibus network. So at first, the monitoring in the diagnostic repeater from Siemens, which will be this is the diagnostic repeater. We'll discuss about it in upcoming slides. Monitoring with the TH link Profibus from softening, okay, and troubleshooting with the Profibus tester 5 from softening. This is the TH link Profibus from softening, and this is the Profibus tester 5 from softening. So monitoring with the diagnostic repeater from Siemens. From by this types of module, we can diagnostic during normal operation condition, where we can check topology, wire break, short circuit in signal lines, missing bus, terminating registers, determining fault location, all while performing standard repeater function. So topological view of the diagnostic repeater is like that. You will have to open the step 7 and select DP master system whose data you want to read. Start the function by the choosing the menu, command view, then display and del all station, only diagnostic repeater with stations, all diagnostic repeaters only. Now we can see the diagnostic repeater view. You can directly check from here. Okay, there is a CPU connected with these DP3, DP1, DP2, wherever it's connected, and what is the cable distance can directly monitor from here. Topology table of the diagnostic repeater. The topology table we can open by the clicking on view and then topology table. You can see the here the distance of the diagnostic repeater and what is the topological determination of the system and what is the cable length distance of the module will be connected here, and the segment DP1, DP2, which segment it's connected, we can directly check from topological table, and you can print it also and export it also, and addresses can be noted in here. So diagnostic buffer, this is the main advantage of the diagnostic repeater. You will get the dedicated diagnostic buffer menu where you can check the what kind of problem or what kind of situation is going in your communication line, that the communication line is breaking. Here you can see break on signal A and or B or terminator is missing. Here you can see the 40 meter and 10.2 meter where the breaking condition have been occurred has been defined. Break on signal A and B, the reflection error is 100%. Check the Profibus and the remedy also we have been here. Okay, here is the statistics buffer of the diagnostic repeater. What kind of proper diagnostic buffer have been come, you can directly monitor from here. Start the function, the choosing option, then statistics. Here you can see the error rate of the particular communication line is for monitor when it's occur. It's also in monitoring, continuous monitoring in the diagnostics statistics buffer. So here is the error message of the diagnostic repeater. The tab DP1, DP2, DP3 and PG each contains the diagnostic for information for the corresponding segment. An icon indicates whether the segment is faulty or noted whether it is deactivated. Here you can see that this is the faulty or deactivated. Okay, DPB slave. Three output field contains graphic and text information on the fault location, type of fault, remedy, and if appropriate information on the reflection fault rate. The details command button leads to the further information, the fault cause and remedy. You can see the remedy and error is present here. DP2 is not communicating, there have error status. The CPU is run mode because of there have OV82 has been connected, the IO missing error. Okay, So you can close, and then after troubleshooting the communication cable, you can directly update it here. Then the communication can be shown in stable here. Okay. So monitoring when the TH link Profibus from Softnik. Comprehensive testing of Profibus DP segment. What kind of solution you can get from it? Stationary diagnostics tool for continuous monitoring, logs and analysis, Profibus traffics and network error, event and timestamp and stored in non-volatile memory. Multiple TH links may be deployed, one per segment. Information accessed via the web browser, alarm via the email and OPC into HMI and SCADA with the optional TH scope software. If you need the operational video of this module, will dedicatedly provide a link in the description below. Okay. So this is the most commonly used industrial thing to rectify or diagnosis the Profibus network. This is a Profibus tester by which we can check the signal test, cable test, storage oscilloscope, protocol analysis, frame recorder, train recorder, master simulation, Profibus PA testing, and with optional adapter and topology. So how we will use this system will we'll see in the next video. So here is the video.
You must create another network for the area behind the repeater and repeat all the steps described for this network. For the actual troubleshooting, you create 3 measuring locations. Click on test locations, enter names for the signs, call them beginning, center, and end. Click OK. At this point alone, the actual measuring locations do not need to be exactly at the beginning and or in the middle, but only approximately. Plug the meter into one of the measuring locations. Select the Signal Quality tab and select your measuring location. Start the measurement. The measurement should run until the red arrow below the green bars has turned 5 to 10 rounds. Stop the measurement. Now plug the meter over and select your next measuring location. Start the measurement. Again, measurement. Take 5 to 10 turns of the red arrow. Now plug the meter to that location and proceed as before. After you have stopped the third measurement, select Cast and save network status to save the measured values. Now the measurements have to be evaluated. 3 measurements are compared. The rating is based on the average level. Average value is also displayed as a number. A principle applies. The worse the measurement result, the closer the measurement location is to the cause of the error. If the worst of the 3 measurement locations is determined, it does not mean that the error is exactly there to but at least it is close to it. Now the cause of the error is further circled. To do this, create 2 more measuring locations. For worst and after worst. Now measure the levels at the 2 new measuring locations. Again, compare the 3 readings. Again, the cause of the error is close to the worst reading. Now proceed according to this scheme until you have found the worst overall location. There is the cause. In our case, the termination at the beginning is missing. This happens, for example, if the shifter on the bus connector is set to on, but the internal switch did not engage correctly. Correct the error. Measure again at least 2 measuring locations. To do this, create 2 new locations. Start fixed and then end fixed. Now the values are much better. When the last measurement is stopped, select Test and save network status to save the measured rate. Now you can do the report. To do this, select Test and create report. The mask that appears, enter the data of the customer, the data of the person measuring, and if desired, a free text. For example, because of the problem. Press continue, then the report will be created. Save the report in PDF format. Close the report preview. Close the report's settings window. Move the mouse over projects. Select your test report and open it with a double click. In addition to the cover sheet, the report now contains all the relevant technical data, such as bitrate, cycle time, and physical values. In this example, we have dealt with the reason missing bus termination. In principle, however, it does not matter what the cause of the error is. The procedure with the 3 measuring locations in comparison stays the same. You must.
So thank you everyone. Have a nice day. If you like this video you watched, please give a like and please subscribe to encourage our efforts and all. And also have a great day from AN Automation team. Thank you everyone. Have a nice day.